All right, let's look at example 2. Same thing, we want to state the transformations, we want to graph, give the domain and the range. So for number 2, we have an A value here. That indicates the slope, okay? But as far as a transformation, it means that it is either a vertical stretch or a compression. And since that's greater than 1, it's a vertical stretch. So vertical stretch of 3. And then I notice I have a +1 inside my absolute value, so h must be a negative number because the minus sign is already there. So this is really saying x minus -1. That's why when I see a +h, that means left. So this is a shift left 1. Okay, now when I go to graph, I always do my shifts first. So I'm only shifted left 1. So my parent would be at 0, 0. I'm going to move this left 1. And then I have a vertical stretch of 3, or in other words, my slope is going to be 3, or 3 over 1. And I count that on the right side. And then I just reflect across the axis of symmetry to get the other side, to create that V shape. So from here, I'm going to go up 1, 2, 3, right 1, 2, 3, right 1. Okay. Now you can draw a little axis of symmetry if you want right here and reflect across it. Or you can count a slope of -3 or up 3 left 1. But that's what's going to give this that V shape that absolute value graphs have. Okay, let's figure out the domain and the range. Okay, so domain is x. We read that from left to right. So if I go and I box this in left to right, don't even really have to do that. I'm running into arrows. Arrow indicates an infinity. From the left, it's a negative infinity. To the right, it's a positive infinity. Or another way of saying that is just to say all real numbers. Okay, to get the range, that's bottom to top. So I box in my graph from the bottom to the top. The bottom is right here. What is that y value? That y value here is 0. So there's a point there, so it gets a bracket, 0, up to, and I hit an arrow, and that arrow is pointing up, so that would be infinity. Or we can say y is greater than or equal to 0.